Hello, this is Phil Thomas from New Era Systems. Today I'm testing another NJT BUC. It's actually made by a New Japan corporation. It's a 3-watt KU band. The model number is NJT-5116F. This is an F-type connector receiving the input from the modem or modulator. As I always do in these tests of RF equipment, I put a dummy load on the back. The dummy load is here to absorb the radio frequency output. You certainly don't want it just spewing out into the air. This is called a cross-guide coupler. It allows me to measure the output of this amplifier. This is a power head. It's connected to an Agilent power meter to accurately give me an output of the wattage or dBm that's being produced by this amplifier. And the final component in this test is a Comtech CDM 570L modem. I use the 570L because it generates 24 volts needed by that BUC, but also it generates 10 megahertz reference. The 10 meg reference and the 24 volts is provided by the modem via this cable. And so it's a very simple arrangement. No additional power is necessary. The modem provides it all. Now I'm going to turn on the modem and we'll start looking at this in detail. To ensure an accurate reading on this power meter, there's a couple of parameters that need to be set up. First is 14.5 gigahertz. That's going to be the place where I start the test. And this offset is 40.4 dBm. This corresponds with the offset on the cross-guide coupler. Although I shouldn't call it an offset, what this is, at 14.5, this is the attenuation. And so when I get a reading on the power meter, I need to add this to it, the 40.48 in this particular case, to get the accurate output from this BUC. So now I'm in the modulator mode on this modem. I'm going to make sure that my frequency is set up correctly. Frequency comes in two different stages here. This is the L-band frequency, but because the local oscillator is set up correctly for KU band, that 1450 L-band translates into an RF output of 14.5 gigahertz, which is the top end of this BUC's range. So this is correct. I'm going to go to next power, minus 24 dBm. That's low and that's fine. It's a good place to start. So now I'm going to go to on off and turn the power on. And now looking at the measurement on the power meter, we're showing 749 milliwatts. In fact, it hasn't even made 1 watt. So what I'm going to do now, I'm going to gradually increase the power and see where it starts to reach saturation. When I say saturation, this means that even though you increase the input power, the output power does not increase in a linear way. It should always be 1-for-1 step. When you get to this point that the manufacturers call saturation, it means you've really got to the end of the usable limits on any amplifier. Okay, resetting the power, manual. It's set now at minus 24. So I'm going to increase it by a couple of steps. I'm going to bring it up to minus 22. You may say, okay, you're decreasing power, but no, I'm actually increasing it because this is an attenuated setting, so that by lowering this, I'm increasing the amount of power that goes through. Minus 22, enter. Now let's go and look at the power meter. We're now running at 1.3 watts, so we're starting to increase. I'm going to do the same on the power setting. I'm going to change it from minus 22 to minus 20. And now the power has moved up to 2.1 watts. Again, that's moving up quite nicely. Now we've moved up again to 2.6 watts. Don't forget, this is a 3-watt amplifier, and the manufacturers call it a typical 3-watt amplifier, which means it's going to be somewhere around 3 watts, maybe a little more, a little less. But the point is, if you need 3 watts on output, this is not for you. You would probably need to go to something like a 6 watt or something significantly larger, so that you have some overhead to be able to push into it in case of rain fade problems that you may experience on the distant end, or we certainly do experience in Florida. Okay, so I'm going to move the power up again, and this time I'm going to move it to minus 17. And the power on the meter is not going up in a linear manner anymore. It should have gone up a little higher. It's hit 2.74. So now I'm going to increase again and see exactly where we are. So on my modem it's showing minus 17. I'm going to increase it to minus 16. Yeah, and we're moving up in a smaller increment. So I think it's safe to say at 14.5 gig, this BUC is somewhere around 2.8 practical output. So now I'm going to change the frequency. I'm going to bring it down to the lower end of the frequency range and see what happens. First, I need to go back to my modem, to my on-off. This is not strictly necessary, but anyway, I'm going to turn the power off. And now I'm going to change the frequency, 14.0. There it is, 950. L-band gives me 14.0 gig. So now press enter. We're going to go to on-off. No, let me just check power first. Yes, I need to change that. I'm going to decrease this power. I'm going to start minus 21. Now I'm going to turn it on. And we're going to see that the power is already outputting at about 1.9 watts. So again, we'll go through the same procedure, changing my power setting from minus 21 to minus 19. And it's bringing us at 2.88 watts. Now this is interesting because to get to this output at the higher frequency, we required a much stronger input. And this is something that we see on a very regular basis. There's different power outputs at different frequencies. And so typically the lower frequency allows you to generate more power on an amplifier. So again, let's just take one more step and see where we're going to be. See if we can reach 3. Oh, one thing I did forget to do on this. There's 2 parameters that I needed to change and I totally forgot. I've got to go to the offset on this, and 14.0, the offset is 39.88. So I've got to change this. In other words, my power meter is not reading accurately. How much difference it will make, I'm not really sure. And now the other thing I need to do is to change the frequency. So I'm going to change the frequency from 14.5 to 14.0, because that's where we are now. Okay, I didn't see very much in the way of a change on this, but just for the sake of completeness, that's where we are. Okay, now finally I'm going to do one more test. Increase the power from minus 19 to minus 18. And we're running at 3.1 watts, which is again where this should be. That moved up quite easily. And so I suspect I can probably push it just one more. So let me just try that. So I'm going to take it to minus 17 now. It didn't move up quite as much as I expected, but it indicates that we're really at the maximum for this BUC. Okay, that's it. Short test. Nothing more to show, so I'll turn everything off and we're done for the day.